Okay, awesome.
So which of the following is an anatomical barrier? Yeah, so it's mucous membranes. That's because it's intact skin, not cut skin. That's an anatomical barrier. And both cilia and diarrhea are mechanical barriers. Which is not a sign of inflammation. Yeah, so it's loss of function, not gain of function. So which of the following is true about fever? And there's multiple answers to this. Yeah, so there's two reasons why it's beneficial. The first is because it allows chemical reactions to occur faster. And the reason why that's important is basically because it's going to allow your immune system to be activated and work faster. And it also has high enough temperatures that it kills some bacteria, so it can denature their enzymes. So is this true or false? No, normal flora is present in the lower respiratory tract. Yeah, so our lower respiratory tract is usually sterile, and it's our upper respiratory tract that has normal flora. Other sterile areas are the cerebrospinal fluid and your upper urinary tract. Which is not a function of normal flora. Yes, so normal flora can actually create an acidic environment, not an alkaline one. Which of the following is a true statement?
Yep, so a flagella in bacteria helps with moving that bacterial cell around, the bacteria around. And then the use of the capsules to help protect the cell from the immune system of the host. And then adhesion molecules can help form biofilms by getting attached to each other, or they can also attach to host cells. But spores aren't a type of bacterial toxin. They are a way for that bacteria to keep proliferating. Yeah, so I think there should be an explanation slide. Yeah, so basically spores help the bacteria persist for longer. So even if the original bacteria was killed off, the spores can keep living on. And yep, next question. Which of the following are not similarities between eukaryotes and prokaryotes? Yep, so both eukaryotes and prokaryotes have cytoplasm. They both have ribosomes, because remember, ribosomes aren't a membrane enclosed organelle. They both contain genetic material as well, except in the eukaryote, it's contained in the nucleus. And eukaryotes do proliferate with mitosis and meiosis, whereas prokaryotes use binary fission. So that's not the similarity. What is not a characteristic of eukaryotes? Yep, awesome. So yes, they do contain membrane-bound organelles. They're bigger and more complex than prokaryotes. And like I just mentioned before, DNA is stored in the nucleus. So if there is a cell wall, and that's normally like plant cells and things like that, there would be cellulose rather than peptidoglycan, which is what you see in bacteria. Yeah, and here's just a list of a few similarities and differences. So there are a lot of differences. But yeah, this is in our slides for week 9. Which of the following are included in the classification of living things? Yep, amazing. So viruses aren't living, so they would not be in that classification. What element in the cell wall of bacteria is dyed in gram staining? Yeah, it's peptidoglycan, except but all these other things can also be found in a cell wall of a bacteria. But the main element that's responsible for that color you see when you gram stain is the peptidoglycan. Yep. So here's just summary of what are the contents of the cell wall, and then so gram positive might also have teichoic acids and lipoteichoic acids, but gram negative might have the lipopolysaccharides as well. And the next question: which of the following is correct? Yep. So gram-positive bacteria will stain purple, and that's because they have more peptidoglycan, versus gram-negative bacteria, which will stain red because it has less peptidoglycan. Yeah, and this is just a summary of the gram staining process. So you first start off with that purple dye, and then if there's no color shown, then you counter stain with the red dye, safranin, and that will show you your gram-negative. Yep. So the rest of the ones that have been listed here are gram-positive, but Mycobacterium tuberculosis is not, because it has mycolic acid in the cell wall, which prevents that gram staining. So instead, you would use acid-fast stain, which is here. And that's just a little diagram of what it looks like. So that's the mycolic acid, and then the peptidoglycan is all the way down here. So you would have to use a different stain. Which of the following definitions is correct? Yep, so the only correct one was the air-tolerant anaerobes. So they won't die immediately due to O2. And then we have a summary slide. Here you go. So there's strict aerobes that need O2 to survive. Microphilic, which is one of the options, they have low O2 requirements, like micro, aerophilic. Facultative anaerobes, they can live with or without O2. Air tolerant means they won't die due to O2, at least not straight away. So that was the correct answer from before. And strict anaerobes will die if exposed to oxygen. How do viruses multiply? Yep, amazing. Mitosis was eukaryotes, binary fission was prokaryotes, and then, yeah, that's not right. Which of the following is correct? Yeah, so herpes virus causes chickenpox. It also causes shingles. Measles virus causes measles, and then the influenza virus causes influenza. Rotavirus causes gastroenteritis, which you guys got correct. And then papillomavirus can cause cervical cancer. Yeah, so this is just a few viruses to know. This isn't the whole list, but just a few to get you started. Which of the following are correct? Yep, they're all correct. I think we should have a summary slide. Yep, so this is just another list of important eukaryotes. So the one I had was Candida albicans. So that's vaginal and oral thrush as well. And some prokaryotes, so I've colored it with gram and negative and positive as well. So there's a few more there. Yeah, next question.
Okay, wait, so yep, so the answer to this is, sorry, necrosis and apoptosis. I just noticed my question. And I just kind of made up the other two, which are another type of thing that cells can do. Condensation mostly applies to chromatin. So it's not really relevant to cells. There should be more in the next slide. Yep, so this is taken from our slides from last week. And basically, it's just showing the different pathways that cells can undergo when they are subjected to certain bad stimuli, I guess. So if it's a reversible injury, then it will remain a normal cell and just learn to adapt. But if it's irreversible, it's probably going to die. So that's kind of the crux of that diagram. Yep, so good job with that one. I think there's more in the next slide, so I can talk about that more. So again, this is taken from our slides, adaptive changes of injured cells. So they can either change physiologically or pathologically. So physiologically means they respond to normal stimuli like hormones, and pathological means they respond to some kind of damage or injury to the cells like stress more general. So the cells will modify their structure and function. I think Akang showed a very similar question to this one, so hopefully this will be easy for you. Yeah, so I just obviously made up bleeding. The other three are very much valid signs of inflammation. Yeah, that's kind of it for that. So again, just to go through this in a little more detail, there's 5 fundamental signs of inflammation. There's redness, which is caused by the little blood vessels in your skin getting or expanding or dilating. We have swelling, which is caused by accumulation of fluid. We have heat, which is caused by fever, which itself is caused by increased blood flow. And there's pain, which is caused by the distortion of tissues, and loss of function, which is basically immobilization of the injured or inflamed area. That's pretty much it. Yep, so I made up the one in blue. All the other 3 are definitely factors that influence tissue response to injury. Yeah, so that's basically all there is to that one, except that with type of tissue involved, that just, so the importance of that is that it kind of indicates how capable the cells are of regenerating, which is covered in the next learning objective after this, the capacity to regenerate. Oh, not the next one, the one after this. Yeah, very good. So can someone unmute themselves and tell me what atrophy is then? Anyone want to unmute? Okay, so atrophy is just a decrease in cell organ and size. Yeah, it's just the opposite, exact opposite of this. This is a little random one for you guys. Yeah, very good. So yeah, it's not changing plates. I just made that one up. So meta plus sign comes from 2 Greek, it comes from plus sign, which means in Greek to mold or change shape, and that's where the word plastic comes from as well. And from what I remember, meta means something new or something changed. So if you put those 2 together, it means mold into a new form. And the importance of that is that metaplasia is basically when cells change or modify some aspect of themselves in response to injury. So that's kind of, I kind of like to use word origins as a means of remembering what the words mean. So I just thought I'd try that as a question. Yep, so just to revise the 4 key terms from, I guess, this whole lecture, we have hypertrophy. So hyper means in excess. So of course it would mean more increased cell and organ size. And by that note, atrophy would mean decreased cell organ and size. Hyperplasia means increased cell numbers, and metaplasia, as we just discussed, means change in cell morphology, which means like cell shape and form. Oh, okay, so no one got the correct answer, which is they always replicate. Oh, okay, well, I guess you could argue. I mean, when I think about it, maybe the answers were a bit weirdly worded, but I guess they always replicate is a better answer than they normally replicate frequently, which is a bit weird when I think about it. But yeah, so labile cells do always replicate. And so can someone give me an example of labile cells in the body? So skin cells would be, yep, skin, that's right. Good job, Jess. Yep, because skin is always regenerating itself, shedding and regenerating. So that's a labile cell. All right. There may be multiple answers to this question. Yep, excellent job. So pancreatic cells and liver cells are both stable cells. And if you remember, stable cells are ones that they do not, okay, they replicate infrequently, typically. So there's kind of somewhere between labile and permanent cells. And there'll be more on that to the next slide. That's a quick revision. Yep, so labile cells always replicate, so like skin. Stable cells normally replicate infrequently, but they can rapidly replicate. So that's kind of the benefit of them. So just as an example, pancreatic cells are stable. So this is why acute pancreatitis is reversible, but chronic isn't. And permanent cells just don't replicate or regenerate like your heart. That's, yeah, that becomes important. Yep, good job. So definitely diet imbalances can cause cell injury for sure, and a lot of diseases. Yep, so that's right. Leakage of pro-apoptotic proteins, which means that it can result from mitochondrial damage, meaning that these proteins kind of encourage cells to die as a result of injury. And yep, increased mitochondrial permeability is more of an effect of another kind of cell injury, which will be discussed in the next slide. Yep, so this is there's nothing really to explain. These are just all various causes of cell injury. Pretty much any kind of trauma you can think of can cause cell injury. Oh, and this is the diagram I was referring to. So as you can see here, increased mitochondrial permeability actually results from an entrance of calcium ions into the cell membrane, into the cell specifically. So yeah, thanks for the. Yeah, that's kind of it for that one.
All right, good. So I found that a lot of the content in my slides was similar to what Savannah sort of covered, but the main sort of takeaway that I wanted all of you to understand was the difference between necrosis and apoptosis. So for this one, obviously, you know, everyone got it correct. Apoptosis is a controlled and regulated process, unlike necrosis. So yeah, next question. So because they're, you know, pretty straightforward questions, I've made the timer a bit shorter as well, so just be ready. Okay, perfect. So I've listed here a few examples of cellular injury. There are sort of 2 or 3 more included in the lecture slides, but it's good that all of you recognize that all of these are examples of cellular injury. So yeah, and then, you know, after cellular injury, it's then up to the cell to decide whether, you know, what sort of pathway it will take. So yeah. Good. So once again, like the big sort of takeaway that I want all of you to go away with is understanding the difference between necrosis and apoptosis. And I think with necrosis, the main thing is it can lead to the uncontrolled release of inflammatory cellular contents. So a good way in the lecture slides as well, in which you can understand the difference is apoptosis is kind of like a shrinking effect whereas necrosis is like a swelling effect, so it can damage nearby cells. And there is two sort of content slides back to back that I've included. And this is kind of, drawing back on that question about cell injury and the different types of cellular injuries. So you have two sort of things, right? One is like you have the reversible pathway. So if injuries within limits, cells can return to a stable baseline, through tissue regeneration or adaptation. But then you have irreversible. So if stress or injury is severe, persistent and rapid, the cell injury is irreversible, and then you have tissue repair. And then if you go to the next one, yeah, and then that irreversible injury is what we talk about with necrosis, and then you have patterns of tissue necrosis based on sort of microscopic morphology. Not too important, but I've sort of listed them out. So you have coagulative, liquefactive, caseous, fat, fibrinoid, and gangrenous. So, when people have gangrene, it's a form of irreversible injury. So the body sort of responds to that. So yeah, pretty interesting stuff. Probably not the most high yield, but yeah, really understanding the difference between necrosis and apoptosis is important. So keep that in mind.
So which of the following divide via budding? You guys did pretty well, but the answer was Cryptococcus. I believe there's an explanation if you move on to the slide. Yeah, so out of the options that were there, Cryptococcus is a yeast, so that divides by budding. However, I think the other ones was Candida. So Candida, it can be a yeast or a mold. It depends on the temperature, but I believe it said at 25 degrees. So at 25 degrees, Candida, it's a mold. So it divides by extending hyphae, not budding. And then the other ones were penicillium and I think sporothrix. But yeah, so the answer there would be Cryptococcus because it's a yeast. Yeah. Yep, so I accidentally went through the answer just before. But so what was the question? Dimorphic exist in yeast form at 25 degrees. So at 25 degrees, they don't exist in yeast form, they exist as a mold. So the answer there would be false. Alrighty, so which of the following does not cause an invasive systemic fungal infection? So out of the four options there, the answer was T. rubrum, so that's tinea. Tinea is a superficial skin fungal infection, so that doesn't go too deep, and it definitely isn't invasive and affect other organs. So the answer there was tinea. If you go on to the next, there'll be a slide explaining the other ones. Yeah, so C. neoformans that causes meningitis, so lung infections, especially in the immunocompromised people. Candida albicans, so it's a yeast and it can cause oral thrush and vaginal yeast infection. So that's especially after antibiotic treatment because a lot of your normal flora has been destroyed. And then you have pneumocystis, and that's fungal pneumonia, so infection of lungs. And then the tinea, that, as I said, it's just a superficial infection. An example would be it can cause athlete's foot. Yeah. Yeah, so the Rose Gardner's disease, it's a subcutaneous fungal infection. So that's when it occurs via inoculation. So inoculation is just a wound from the rose thorn. And I feel like that's kind of like a buzzword. So whenever you hear that, the answer here is sporothrix. So the likely causative agent of rose Gardner's disease is sporothrix, which is a subcutaneous fungal infection. Yeah. Yep, and that just explains it, what I just said. Yep, so that's true. You guys got that. But yeah, another point, it's important to remember that Aspergillus, that's not a part of our normal flora. I remember noting that last year. But yes, Candida is a part of our normal flora, but it can cause an infection if you have what do you call it? Sorry, just had a mind blank. But that's okay. It's part of a normal flora. That's all you need to know. Yeah, so it's an opportunistic pathogen, so that's what I was trying to say, and it can become invasive during antibiotic treatment.
Yep, well done. So the question is, which of the following are possible outcomes in response to injury, tissue injury? So all of them are correct. So it just depends on the severity of the tissue injury and whether the tissue can recover. Next. Yep, well done. So for the blue one, instead of dilation of blood vessels, so for hemostasis, what happens is the blood vessels constrict, so vasoconstriction, so that the blood flow basically slow down, and it is easier for it to form a platelet plug, and then for the fibrin clot to form as well. Can move on. Yeah, so the image shows healing by first intention. So that's when basically you have like a clean cut, and the basically the two sides of the opposing side of the injury is close together. And if we go to the next slide, we have a picture of healing by second intention. Yeah, and as you can see, what happens here is you have granulation tissue that kind of forms from the bottom of the wound, because the wound is kind of deeper and bigger. So it's like the side of it is not kind of close together. So you have to heal from the bottom. And the granulation tissue is basically like connective tissue and microscopic blood vessels. So like that's the difference. Yeah. Ooh. Guess that's the end of the Kahoot. Well done, cat face. Love cats. And is this a smiley face or not? I don't know what that's called, but it's like a
smiley face wings.
Yeah, that's a real smiley face. That's why that's why I won, because it's a real smiley face, not a fake. Whatever. Well done, everyone.
Good job, guys. So this Kahoot will be available on our public Kahoot collection after this lesson, and this video will be uploaded to YouTube over the weekend. And if you have any questions over the week, just make sure you drop them into our question feedback submission form, which is available in our group description. Thanks for coming, guys. Hope you learned